Recently I discovered a YouTube live stream of these two guys, Komi and JB, making their first games from scratch in C. They've just released the games, which you can find linked in the description. Their channel is HandCraftGames, and while hanging out in the chat, I asked if they'd like me to review their code. Today I'm going to look at Komi's game, LikeRogue. First, let's run the game so we have context for the code. This is a nice title screen. Okay, it's WASD to move. So here we have a merchant. 1, 2, 3. Floor is 1, we have health, strength, gold is 0, so I'm going to guess the merchant isn't going to be much use to us, but let's walk over to him. Merchant, come back when you have some coin, traveler. Here we go through the door, you venture deeper into the dungeon, and there doesn't seem to be anything inside this room. Here we have an enemy, G. Ah, that's nice, ASCII art right there. Enemy, strength. Gosh, that blue is hard to read, really. Enemy will buff for 2. Combat started. Okay, so these are the messages from before. Goblino approaches. Combat started. We have 50 health, 5 strength, 0 defense. Enemy will buff for 2, so it has a kind of Slay the Spire thing where it tells you what the enemy's going to do. We can attack or self-damage and scale 2. I don't know, I might be overthinking. Let's just attack and see what happens. Attack for 5, okay. Attack Goblino for 5 damage. Goblino buff to 2. Now enemy will attack for 2. Right now we're attacking for 5. Let's see what scaling does. Now we're going to attack for 7. Okay, that's nice. My defense went up when I scaled up. My healing hasn't gone up, but the defense amount went up. So now I'll only take 1 damage. He's going to buff, so I'll attack. He'll attack for 12. Jeez, this is a lot of damage now. He's going to buff. I'll attack. He's going to attack for 14. Wait, I can kill him now, right? He's on health 5. Okay, so I can just attack. Okay, and I didn't take any more damage. That's good. I think we have a good idea of how the game works, so let's get into the code review. Not sponsored. Buy my game, NSMG, on Steam, and leave a positive review. And first thing I need to do is build the project. I don't see any build script. Maybe the README, the tutorial for how to play the game. So it looks like there's no build script. From what I saw on their streams, they were just repeating the same console command to build it every time. I'm going to use Clang just because it integrates well with Clang D, the language server. And most beginner projects just do something like this. So let's see, game.c, gamestate.c, input.c. map.c. Obviously, you could make a bunch of separate commands to build all of these as individual object files and then link them all. But let's just see if this works. And I want to output a.exe. Bunch of warnings and a couple of errors. So what did we get? Unknown type name bool. Do we just need standard equals? Let's do GNU2y. I think that's the latest available. Ah, there we go. So we're just using some more recent C features. I'll test that in a minute, but let's make a build script now. All right, there we are. And we'll make this multi-line so that it's easier to work with. And I'm going to add a few things. GDB debugging symbols. And we already have some warnings, so that might be the first thing I start with. But let's create a build task /build.bat. And let's create a debugging setup. Pre-launch task is build. Okay, so now I can just press F5 to build everything. I don't actually want to run the program, so let's just put a breakpoint right there and then hit F5 to run the task and debug the program. And there we are. We've hit our breakpoint, so everything's set up. Pretty sweet. Okay. So for this code review, this is my first code review video, so you guys let me know what you think, but I'm just going to play it by ear. Let's see what we have. So first let's look at some of these warnings. Comparison of array equal to a null pointer is always false. So let's just fix these warnings first. Get rid of these warnings. Then I'll add some more compilation options and see what we get. G current enemy name equals null. So name is an array of characters, which that can't be null. So this isn't a pointer. He's checking for null, but it can never be null. So this probably one of those things, I guess. But this check here is doing absolutely nothing. This isn't a pointer, so it can't be null. So let's just remove that. Next thing, a format string is not a string literal. It's better to pass the format string, which with an S telling it to find a string in a variable over here. So here's an example showing why you don't usually want to pass a variable in as the format string to printf. So like I said, this first argument in printf is a format string, not just a string that's going to be printed. Here I have my string. I want to print I love %. And printf is not going to just print this to the screen. As you can see, it's printing I love some random nonsense. Because what %s means in a format string is that the next argument in the variadic arguments of printf is going to be a C string. So if I add a string here, then printf will interpret that as what this format specifier here is referring to. So unless you're specifically constructing a format string in your code, you don't want to pass it as the first argument of printf. In order to print this string out correctly from printf, we should use the format string to say I want to print a null terminated string, and then pass in that null terminated string as a separate argument. Okay, what else do we have? We just fixed that one. Okay, we're going to have a lot of this. I'm just going to copy that. And okay, I've already seen some code we want to change anyway. Let's get rid of these ones. Okay, so another instance of the printf. And is that it? Is that all the warnings we had? Okay, so now we've cleared away those warnings. Okay, so now let's modify the build script and let's add -w_all-w error. I usually compile with these. In fact, I pretty much always do. This enables additional warnings and turns all warnings into errors. Just makes you fix everything that might be broken. It helps the compiler help you catch problems rather than running into weird issues. So now we have a bunch more errors. Unused variable prev gold. We'll get rid of that. Rooms max we're not using. Lots of unused. Floor min enemies. That seems like something you want to be using. So we'll get rid of it for now because it's unused, but that seems like a logic bug for sure. A lot of times unused variables are, with this one, for example, rooms max. He's just giving himself this value so that he can easily reference it, and then he didn't end up needing it. That's fine. So a lot of the time unused variables are not a problem, but sometimes they are. Sometimes if you have an unused variable, it's because you made a logic error like this. We'll see later, I guess, in the code review. That seems like a logic error. Okay, misleading. Ah, yes. This is classic. An if statement with no curly braces, followed by two statements. So statement is not part of the previous if, valid turn equals 0. So by the look of the way the code is formatted, valid turn equals 0 is supposed to only happen if input is not equal to 0. I don't actually know whether that's the case or not. But because there were no curly braces around this if statement, this second statement here was not enclosed by the if. So hopefully that was a bug we just fixed, but we can go through later and find out. Now another unused variable rooms max. Seems like he never uses that. Unused variable call. Unused variable line, so we can get rid of that. Unused variable message buffer. Interesting. Screen render combat, and he made a message buffer of message size and then never used it. So this is probably just old code that got left and never removed. Screen height is also unused. Okay, so if we get rid of all of that and we build, now we have no errors and no warnings. Great. So these are just compiling with w_all-w error, and this works on GCC and Clang. Just lets the compiler point out potential issues. The compiler doesn't always know what you intended to write, but the compiler developers have programmed in a bunch of different patterns that they can recognize where mistakes usually happen. And this just helps you fix them. And clearing these up makes your code generally more clear. Your intention's more clear when you write your code. So the last thing we're going to add in here is -mj compile commands.json, and that is going to output a file when we build. This is the reason I often use Clang, so that it can output this file, which is used by ClangD, the language server, to tell ClangD how each file is compiled, and that way you can get the nice IntelliSense inside your code, and you can click on a variable type and go to the definition of it and all that. So it just makes your IntelliSense work a lot better. So this game is LikeRogue by Komi. It's his first game ever in C, and I guess my first bit of advice is just to make yourself a build script, or in some way write down how the program is built. Sometimes I might just leave a comment. If I'm making like a single file project, maybe I'll just leave a comment right at the top that says like to build, and then, you know, clang, main.c, etc. Right? Or put it in the README file, or the easiest way is just to make a build.bat file, and that way you're always able to build when you come back to this 6 months from now. You don't have to remember how to build it. Okay, so let's just start taking a look at the code. I'm not even going to step into it yet. So let's start off at the entry point of the program. We have main, we're setting the random seed, classic C programming right here. Then we have game G. So this is a variable declared on the stack. Game sounds like a really big structure, so let's go have a look. So this is a big structure, 5 kilobytes, containing all the game data by the look of it. And I'm going to go ahead and guess there's only one instance of this structure in the whole program. Let's find all references. Okay. And do we ever declare another game variable? We don't seem to in game.c, or in game.h, obviously. Game state.c. You're passing around a pointer to this everywhere. There's the one. Okay. So this structure is 5 kilobytes. You're making a single copy of it anywhere in your program. And right here, you're putting it on the stack. Anytime you declare a variable like this inside of a function body, the memory for it is on the stack. The stack is a limited resource you have for your program to use. It's like working memory for just small variables and stuff like that. You really don't want to be putting something on the stack if it's going to last the entire runtime of your program. There's no need to take up stack space with a 5 kilobyte structure that you create at the start of the program and use all the way until the end, right? So we can just either move this to global scope like this, or alternatively, we could make it static. People don't like using the static keyword because if you ended up running this code on multiple threads or something, then they'll all be referencing the same game object, and that might not be expected. But I think game G just being in global scope totally makes sense. I don't like that it's called G, but we'll see if we run into any name collisions. Let's just see if we can compile with this game G in global scope, or if that causes any problems. Okay, so that compiled no problem. Now I see we're passing around pointers to this game object. So now that this is in global scope, the compiler is free to either allocate this in static memory inside the executable itself, or for the C runtime to allocate this in memory before it even gets to your main function, as I understand. That just means it doesn't take up stack space, and it's probably never going to fail. If this goes into static memory, the operating system knows about it when it runs the executable, and it doesn't have to separately allocate memory for it or take up some of that stack space. Then we can also refer to this directly throughout the program, just with, G dot, oh, I want the current enemy, right? I can just refer to that anywhere in the program rather than having to pass a pointer around. So let's look at everywhere we're passing a pointer to G and change that to just reference it directly. So we have game.c. A really quick fix for this is to go like this. So all of these files are going to have the game type. I'm just going to put extern game G in each of these. And then we can get rid of all the game star. Okay, game.h. That doesn't need any. Game state.c. That's also receiving the game. Main.c we already know. screen.c. Sure, I'll put this down here. Actually, I'll put it up here. So in C, each of these .c files is generally compiled separately as a separate translation unit and then linked together. So if a translation unit is referencing a variable called G, but the variable is not, locally defined, right? It's not actually in this translation unit. You can tell the C compiler that it's external to this translation unit. And then it'll leave it for the linker to find this game G variable to link in. We are compiling all of these objects into a single translation unit, so the linker won't actually have to do it, as I understand. Now we have all these external game Gs, we can get rid of all of these pointers to G. So we have some with comma, so let's just get rid of all of those. And that looks fine. And then get rid of all the ones that are just a single argument. That looks good. And then G pointy, we can replace with G dot everywhere in the program. That might, if we have something ending in G, like, just a variable name that ends in G and we're using it as a pointer somewhere, that could be incorrect. So let's just try to look through. You were dereferencing this G pointer about 1 trillion times in your program, or I should say 291 times. And it all seems totally unnecessary because there's one game object in the whole game. Let's just replace all of those. And now see if that compiles. Okay, we have a ton of errors now. That's because I changed the definitions and declarations of the functions, but not the call sites. So we want to change opening bracket G, comma. We want to replace that with opening bracket nothing. That looks good. And I'm guessing we're passing G once we already have it as a pointer. Yeah. That looks good. Okay, and then we're probably passing it with no other arguments a bunch of times. Oh, well, we don't. Okay, so I just want to change these instances. Yes, we don't need to pass G any of these times. And are we passing and G? Yes, okay. Now let's see how we build. Okay, fewer errors. Use of undeclared identifier G. So collision.c also needs an extern game G. And memory reference type message log star is appointed. Did you mean to use? Oh! I accidentally changed that when I was changing. Okay, well, we can't change this everywhere. Not message log.h. Okay, this looks right. And we don't want to change that. Okay, so these should be good. And message log is not a pointer. My bad. Okay. Nope, can't change them all. Only in this function. Okay. Because we have a local log. I'm going to look into what that code actually does later. I'm just getting it building. There we go. Okay. So we're building again. Let's go back and give a little summary of what I did. So we had this game object, which is a 5 kilobyte structure. And we were declaring it on the stack and then passing around a pointer to it everywhere in the program, even though there's only one game object in the whole program. So it's much better to just declare this in global scope and then reference it directly everywhere in the program. And then you don't need to, it's more convenient to not have to pass pointers around, and it's actually faster to access the memory directly in every instance rather than through a pointer. Okay, so now let's have a look at what this game init function is actually doing. So the message log, you know what, we should initialize this probably to 0. Otherwise, we could have just arbitrary values in this memory. But the message log is initialized. Message log equals message log in it. So let's, since it looks like we're doing a lot of initialization of this structure, let's open this up on the side. And there's our game structure. So we have a message log, which we are initializing. I want to go look at what the message log type is. Message log is a 1.2 kilobytes with a bunch of messages. Okay, so that's fine. But why are we calling this function? Okay, and we're passing back a message log. So this is a little crazy. Do we use message log init anywhere else in the program? So right here, what we're doing is jumping into the message log init function, creating a 1 kilobyte message log variable on the stack, initializing it with these ... messages, and then returning it to be assigned to g.messageLog. So I don't know why we're not just operating on g.messageLog directly. You could either pass this in as a pointer to this if you want to be able to initialize different logs, or if this is the only log in the game, which I would assume is the case, we can just operate on it directly in this function. So let's have a quick look. We have message log init being called, and then there's the definition and declaration. So message log init is only being used right here, and it's only being used to operate on g.messageLog. So we can just create an extern game G. We're going to need game.h, and then instead of working on log, we can use g.messageLog, and we don't need to return anything. That can be void. So instead of creating a 1 kilobyte structure on the stack and passing it back, we can just operate directly on message log. Now, when we were creating that, let's have a look. We weren't initializing this with any data. So it's probably fine to just, this is the exact same code again, leaving the memory empty. But we might want to reinitialize. Oops, there we are. There we go. This just sets the message log memory back to 0. Might be a good idea to clear this to 0, and then next and count are going to be 0. It looks like we're going through all the messages and setting them all to ... but then we have this variable called count. And I would assume we're only ever printing out messages up to the number of count, right? So probably we would never print these messages, but it's not a big deal. Let's go back to, oh yeah, we don't need to assign that to anything. And that's probably building just fine. Yeah, so now we're just actually operating directly on the message log inside the game object. Now we're setting stats to 0. Probably we can set the whole game object to 0 before we do anything else. And game state change, GS main menu. Okay. So let's go have a look at what we're doing in this function. Let's get rid of message log. Game state change, int state. I feel like this should be an enum. We're switching on the state. This looks very enum-ish. So I wonder why we're passing an integer. Let's go have a look at this. So we actually have this enum, game state. So that should probably be an enum. Why is it not picking up my header files? Anyway, I'll just open up gamestate.h. Gamestate.h is including gamestate.h. That's copy-paste error, I think. And gamestate change can now take this enum. Just verify that that change was fine. Okay. So now that we're passing in an enum, we're kind of giving more information about what this variable should contain. We're switching on the state, and this is how we change states. If it's main menu, we clear the screen, set the state to main menu. This is kind of bug prone here. We've already passed in that it's the variable the value we want. So why are we writing it out again here? This should just say g.state equals state, right? And then break. Map is clearing the screen. I'm seeing some repeated code here. So the only state, every state clears the screen and then sets the state to whatever it is and then breaks. But only the combat state does anything. So I'm thinking we should just clear the screen, set the state, and then we can combine, there we are, we can combine all of these to do nothing. And that way we can see only in the case of combat are we actually doing anything extra. Let's just see that that compiles. So you could also just do an if statement, right? If state equals gs combat, and then do this extra stuff right here. It would be fine. However, you get some extra benefits using the switch statement. So we're operating on an enum, an enumerator, which can have a limited set of values. And by having all of the values inside the switch statement, this is called an exhaustive switch. So we're dealing with every possible value that we could be switching on. So if I remove main menu, for example, right away I get this error, enumeration value gs main menu not handled in switch. And this is nice because say I want to later add a new game state. Fun. Probably should have made sure the fun game state was here somewhere to begin with, Komi. That's a hot tip for you. But now, when I save this, now we have an error here. And if I try to compile, since I have warnings turned into errors, enumeration value gs fun not handled. So if you use exhaustive switch statements like this, you're basically making it easier for yourself later when you change or add a game state. You can be reminded, oh yeah, I need to go address that game state in this place. So anywhere I need to do something with all game states, I get an error now telling me that I have to go fill out the switch statement for that game state. So that's why passing in as an enum is a lot better than just passing it as an integer. I also like to put curly braces around my switch statements or my cases. It doesn't do anything in this specific instance, but if we were declaring some variables, and say we were declaring some variables over here in a different case as well, if they're inside the curly braces, they're limited to that scope, and we can have separate variables with the same names, or variables that aren't accessible by other cases and stuff. And so this just makes it safer to enclose all of your case code like that. Okay, let's see where we were before we got to game state change. We were just changing that to main menu, setting the floor to 1, and generating the map. I wonder, do we ever call generate map with anything other than g.map? Map generate g.map. Yeah. So this is another instance of a function that always operates on the same data. You don't need to pass in that data if it's the same every time. Let's get rid of that. Get rid of that. Extern game G. And then M is going to be g.map or something. g.map dot. There we are. And map.h, there we go. I hadn't saved map.h. Now we don't need to pass in g.map in either of these locations, and we'll just see if that still compiles. Use of undeclared identifier M and g.map. Okay, so this seems to be a pervasive pattern that Komi has done. I want to say, I don't want Komi to take this as some kind of insult. I actually really encourage people to just make something the way you know how. So I'm really in support of this way of learning, because you can figure out the better way to do it later. The fact that you get it working with the limited tools is admirable in itself. So let's have a look at carve room now and see if that's the same thing, if we're always passing in g.map. G.map. Yeah, okay, so this is the only place we even call carve room from. So we don't need to pass in g.map. Carve room doesn't need to take a map pointer, and we can just directly access g.map and not pass it in as a pointer there. And there we go. So we're doing map generate. I think we can presume what this does. So let's have a look at this map structure. Here it is. We have map data, which is a two-dimensional array of characters. The map height equals map height. Is this ever, g.map.height ever not map height, I wonder? Probably you could just use the constants directly. But that's okay. This seems like the number of terminal characters, 24 high by 80 wide. Yeah, seems like number of characters. Map height over room height, so with 8 high, 16 wide. Interesting. So that's fine. So these are just constants. Does this ever change? I'm already seeing, we're declaring these as variables. I'm just going to put const here. So if you have a variable that's whose value doesn't change, you should just declare it as constant. For one, it helps prevent you from making mistakes. Let's compile that and see that I was right. Yeah. For one, if you don't intend to ever change this, making a constant prevents you from accidentally changing it, so it prevents you from making errors. And for two, this tells the compiler, whatever this value is right here at this point, it's never going to change. And since this value was calculated based on two definitions, which are known at compile time, you know, this value is compile time known, this value is compile time known, so the result of this equation is compile time known. Now that the compiler also knows it's constant, it knows this is a compile time known constant value that never changes, so it's going to know 24 over 8 is 3, so this room's height is always going to be 3. It's constant, it's always going to be 3, and if you don't pass the address of this to anything, then it's going to know that you're just using the value 3 and be able to just throw 3 in wherever it sees room's height instead of having to access the memory where that variable is stored every time. So the constant, yeah, it helps you prevent you from making mistakes, and it gives the compiler more information to optimize things. So I would basically say make things constant when you can, and only make them variables, which means not having this constant keyword, when you need to. Okay, so we're setting the start x and start y to 0, end x, end y to 4, 2. These feel like they should be randomized, but maybe that happens somewhere else, I'm not sure. Then instead of continuing, well, this would have been through pointers before, right? So he's made local variable copies of these. Do these ever change now? Can I just make these constant as well? Yeah, so those can all be constant. Now we're iterating through the rooms, the rows and the columns to set g.map.rooms, that to 0, and the rooms are integers. Okay, we have a two-dimensional array of integers for each of the rooms. I wonder what the integers values represent. So we're setting them all to 0. Then we're iterating over the rooms again. So I think we can just put that right there. And we're setting g.map.visited to 0. These could be mem sets as well. I don't mind leaving these as for loops because it's very clear what you're doing. But if you wanted to, if you found that this was slow in the future, you could replace them with mem sets or something. So now we're iterating over every cell in the map rather than just every room, every single individual cell. And we're setting every cell to a wall, which is just a character. Okay, so that's what these are. Just a character. Map data. Map data is an array of characters. So this is what you actually see rendered on the screen. Okay, these are all the cells you see rendered. And we're setting everything to a wall to start with and then carving out the map. Make a path from start to end. We're starting at X and Y. And we're looping until we get to the end. Okay, we set the room to 1. It's not clear what 0 and 1 mean. We're setting the rooms to 0. Now we're setting them to 1. Wonder what that means. If it's just the existence of a room, we could just make that a Boolean, right? I'm curious if we ever use values other than 0 and 1. Let's just make that a bool and see if we get some errors. Okay. So we're only ever setting rooms to 0 or 1. So it's more clear if this is a bool, because it's about the existence of the rooms. I might even call this, if it were me, I might call this like room exists, right? Because that's what this value represents. But we're calling it rooms, and we're setting it, I'm going to set it to false. Okay, I don't know what the hell's going on with ClangD that it isn't figuring out that false is fine. But I'll just leave the red squiggles there. We're still getting our, you know, we can click on things and get to them and stuff, so it's fine. This is one of the reasons I hate developing on Windows, by the way. Things just go wrong. Windows is not an operating system built for developers, and, you know, partly it's the tooling, right? But since most programmers tend to work on Linux and tool developers work on Linux, everything programming-wise, at least for C, just works on Linux a lot better. So I don't touch Windows if I don't have to, but here we are. Here we are on Windows living. So we're trying to get to the end. We set the room we're in right now to true, which starts at the start X and Y. And then 50% chance to do this or this. If X is not end X, then X moves toward end X. Okay. This is nice. Or if X is already at end X, then we move the Y. And the other 50% chance, we just do Y first. Okay, that's not bad. So we just step toward the end from the start. And we tend toward the X or the Y, depending on this 50% chance. So we're carving a path of existing rooms from start to end. Then initializing some random rooms. I wonder why he's done this for a 50% chance here, and then this for a 50% chance here. I mean, this makes it clearer that it's like you're thinking in terms of percentages. But this can just be rand modulo 2, and it should be the same. So if we're not on the bottom, and the room down one from us exists, or we're not on the top and the room above us exists. So if there is a room connected to us, is what this says, then make this a room as well. This might already be a room as well. This is kind of, okay, every room has a 50% chance, every potential room has a 50% chance to become a room if there is already a room connected to it. This seems like a really bad way. It might help to illustrate this. We have a grid of rooms, horribly rectangular and not square at all. And let's say this is the start, and I'll put an E for end. And at the start, we're generating a random path from start to end. And let's just say it happens to go like this. All of these rooms now are set with a value of 1, and then all the rest are still zeros. So as the code shows, we're iterating over the rows and then the columns, then checking a 50% chance, then if there's a neighbor, enabling that room. If 0, 0 means top left, it'll start up here, which means it would go okay. But let's assume 0, 0 is bottom left, just to demonstrate like the worst case scenario. So it would go to the first room and say 50% chance to even look at it, then is there a neighbor? No, this is going to be a 0. And the same would happen, all of these would be zeros until you get to this one. Then 50% chance it even looks, and it does have a neighbor, so it would be 1, right? So this one would have a 50% chance. And now you get to, this one would have a 50% chance. This one here, 50% chance to check. Then only if this one has already made a room would this one become a room. Okay, so that's, and you're only going through this list of rooms or grouping of rooms once. So that's why it's a problem. I suspect, since the rooms seem to generate okay, 0, 0 probably is actually the start right here, which means, you know, these are already rooms, so the logic doesn't matter. Then we get to this one, and it's a 50% chance to check, basically a 50% chance to make this a room because it does have a neighbor. But if the 50% chance doesn't roll on this, and that doesn't become a room, then this one, it doesn't matter. Even if the 50% chance hits, this stays a 0 because it doesn't have a neighbor right now. And later we may end up getting to this room and, you know, well, let's say this room got created, then this room gets created. Even though these rooms get created and this room hit on the 50% roll, it already got passed, right, in the search. We already went through that room and weren't able to set it to a room because it didn't have a neighbor. So I don't think this algorithm is working exactly how Komi intended. So this was something I posted on Reddit 7 years ago. But there's a maze generation algorithm. So there's a start point and an end point, and then the color shows how far each point is from the start, right? So it goes from red to blue to green back to red. Maze 95. I actually made a maze game, 3D first-person maze game, 7 years ago, and I made my own algorithm for that. It's on my back when I used GitLab. You can go find my maze algorithm in here somewhere. Yeah. Anyway, there's a lot you can do with generating mazes, and you know, hey, you got this working just by figuring it out yourself. I totally recommend people, like I said before, do it the only way you know how. Do it the bad way with the limited set of tools and information you have. You'll get a lot of experience, a lot of context, and then once you've done that, go look up how other people do it. And having that initial experience of doing it your way, which is almost certainly going to be a bad way if you don't have a lot of experience, but it gives you so much understanding of what you're doing. Then you can go and learn the canonical ways of doing things. And I think this would be a great time, Komi, for you to look at maze generation algorithms and go try them out. And, you know, you can go do Dijkstra's algorithm and Prim's algorithm. Yeah, and go have some fun with maze algorithms. You'll be amazed by the things you can do. Pun intended. It wasn't intended, that came out randomly. And I'm sure you'll have a lot of fun learning about maze algorithms. Then we verify that the start room exists, although that's inherent since we start at start X and start Y and set that. We really don't need this line. And then we verify that the end room exists. I feel like that should happen here, right? We go from start to end, and then once we arrive at end, we should add that room on. These are just minor logic tweaks, really. The whole maze algorithm should be replaced with something good. Carve out the random rooms. Oh, okay. So this was assigning rooms to exist. So we've just set this variable to say this room exists. Then we're actually doing something else. We're iterating over these cells in the map data and setting them to empty floor. Okay. Then adding doors. Let's see. We're iterating over all the rooms again. This rooms variable was an integer. I changed it to a bool because I thought he was only using it that way. He is even doing a truth value check here. He's treating it like a bool. This is equivalent to checking if equals 0. But yeah. So I wonder why he didn't have that as a bool before. Probably just made it an int initially, but he seems to use int most of the time. So we skip empty rooms that don't exist, and then we check if the room to the right exists. Then add a door on the right of the room in the middle vertically. And I guess this is the same for the left, down, up. So that's just the top left, right, and down edges of the room get a door. And it looks like everything's a double door. So you add one door on the right of this room, and then when you come around to the room that is to the right of it, you'll add a door on the left of it as well. We kind of have like double thick walls and everything. It's a little unnecessary, but it also doesn't really matter. Okay, then we add a stair to the end room. Nothing wrong with this. And the merchant gets added to the exact same place every time. He seems to like his intermediate variables. There's nothing really wrong with it. If it improves readability for you, you could just put this directly in the square brackets. But then if you think that's unreadable, you can do it like this. Still, these may as well be constant at least. I probably missed a couple of things that could be constant as well. Just a signal that you're not intending to change it and let the compiler know. You are also like polluting the scope with a variable called starx now that you didn't really want. You can decide whether this is worth it or not, but you can put a little scope around things like this so that these variables only exist here and don't leak out to the rest of your code. If you have a long function or a big scope and you start doing this kind of thing, making little temporary variables, and aliases for things, you can get a very polluted scope with a lot of different names declared. So this can help in those cases. It's not really necessary here. Just a little tip. And we're setting that to merchant. Okay, and then the map is generated. I've only gotten halfway through the game init function, but I feel like I've gone over so much already. This is my first code review video ever, so you guys let me know what you thought of it. And I guess if I'm going to review the entirety of this code, it's going to have to be a series. So this was LikeRogue made by Komi of HandCraftGames. And HandCraftGames is 2 people. The other guy is JB, and he made a game called Chudbuds, which I've been planning on reviewing the code of. But you guys let me know whether you want me to continue with this review of LikeRogue from Komi, or whether you want me to review some code from Chudbuds next, from JB's game. Cheers!